Hello everyone and welcome. First of all, I would like to thank you all for taking part in this event, which will certainly be the first of many. One thing that this pandemic has taught us is to work harder and better using the technology that is available to us. My name is Alfeo Bonato. My role in Bausano is Technical Sales Manager, and I've been working in the world of extrusion since more than 30 years. Here with me is our Vice President, Clemente Bausano.
Thank you, Alfeo. Hello everyone, and thank you for being here.
Giovanni Bausano, who is responsible for the R&D department, is also with us.
Hello everybody, welcome to Bausano.
We are also connected to Alessandro Ruotolo, our extrusion test manager, and with the colleagues who are working on the machine to allow you to observe the live testing.
Thank you, Alfeo, and good morning, everyone.
Well, I now give the floor to our Vice President, and then we'll get to the art of testing.
Okay, for those unfamiliar with us, Bausano has been a family-run company manufacturing and producing extrusion lines for plastic processing since 1946. For over 70 years we have focused on quality and have distinguished ourselves for the flexibility and attention paid to every single need of our customers. In the 80s we launched our multi-drive transmission system on the market that characterizes all of our twin screw extruders. We will be giving you more technical details on this further on during the event. Here in Bausano, in the design phase, we study the best solution for your business, customizing our machine with you in every single detail, and this has always been recognized as one of our trademark. Each extrusion project of our customer is unique, and that is why it requires a preliminary study and a specific screw design for the type of material to be processed and for the product to be obtained. Today, we believe that the way of conceiving the production and consumption of plastic must radically change if we want the cycle we are part of to be sustainable and replicable over time. The cost of production and use of plastic products must not be evaluated simply in economic terms, but now more than ever, in terms of impact and therefore of environmental cost. How we did interpret this need in Bausano? What has been clear to us for some time is that the cost understood at 360 degrees of the process and of the product must weigh as little as possible in terms of resources used. We have identified the energy consumption of machinery as one of the main points to work on, both because this is one of the main items of expenditure for extruders and because the production of energy has a cost that goes far beyond the money it takes to pay for it. The use of more efficient motors on our extruders is in line with this, as well as the option of equipping them with the electromagnetic induction heating system. In addition to being more reactive, fast and precise, allows us to achieve energy savings up to 30% compared to the traditional ceramic heaters. Now I will hand over to Giovanni to go into details of the line that you will see in operation today. Giovanni, up to you.
Yes, Clemente. Our technology enables us to produce a versatile machine. In the main part, for production of 5 product categories: granules, medical products, profile, pipes, and lastly, the working of special material, for instance, wood plastic composite. Our products range consists of counter-rotating twin screw extruder, which represent our core products, and we have continuously designed and produced single screw extruder as well. In fact, in 2019, a new single range called Ego for manufacture profile and pipes was launched. These extruders are able to work a variety of plastics materials, for instance, rigid and flexible and application, namely multi-layer and monolayer pipes. Today, we will looking testing of a line production granule using Bausan Nextomover 9225. The configuration of Nextomover provides a multi-drive system, high energy efficiency motor, digital extruder control using a 21-inch touch screen, smart energy induction heating applied to the barrel. The material to be worked will be PVC foam for shoes. We will be able to monitor the main parameters relating to extrusion process thanks to the digital extruder control 4.0 system. The new series of MED Nextomover offer an outstanding technical innovation in the field of granule production. The Twin Screw Extruder Nextomover keys feature are its energy saving capacity up to 35%, achieved through the installation of our patented multi-die system and our induction heating system of the barrel. Alfeo, would you like to tell us about the patented multi-drive system and the smart energy system?
Yes, Giovanni, thank you. The great hallmark of our twin screw extruder, which has been designed in the 80s and since then constantly perfected, is a multi-drive patent. Multi-drive is our special gearbox that has been conceived to support high-performance screws. Main problem of our customer was to have, in the 80s, higher production as well better dispersion machinery. The increase of performance linked to the new design of screws was a key role in obtaining such advantages. But the main problem is higher performance for viscose materials like vinyls, wood polymers, SPC, is the higher viscosity and the torque generated in the screws processing the material. This torque generated was giving a very high thrust bearing and back pressure to the gearbox, where the traditional gearbox had no capacity to support the new design of screws. That's why we have been hardly working after the screws design in developing a very high performance gearbox. The generation of traditional gearbox has the limit for the twin screw extruders in the 100% of torque that is supported and transferred through each teeth of the gear, while we have been working to overpass such a limit, and the generation of a 4 motors gearbox was allowing us to obtain on each teeth of gears 25% only of the torque generated. Automatically, the total torque has been multiplied 4 times bigger than previous gearbox. This is the first effect that has been supporting our screws, but it's not the only one. Truly speaking, the 4 motors that we have been working on has been, with a total kilowatt of power installed, much lower than previous single motor gearbox needed for the same throughput. The side effect of our gearbox was also, apart from generating higher torque availability, also a very strong reduction in the kilowatt needed and absorbed really during the production. Another side effect that gave strong advantages and benefiting our customers was also limited space and shorter length of the gears, tooth and components. All the shafts of the gearbox are also shorter. This is also a very important role because the torsional effect transferred from the screws to the gearbox with the shorter shafts reduce the risk of torsion and creeping of the shafts, automatically giving much stronger possibilities to support the higher output of our multi-drive extruders. The total lump sum of our patented system was much higher output, lower kilowatt obtained, and a much longer life of the machine itself. Our extruders for dozens of years are fully working in the worldwide market with no need of special maintenance and keeping very strong life of the components. Another part as an effect we are working on is the induction heating system. What's the induction? Induction is what mainly use your wife at home, or if you like to cook your dinner, you are using yourself the induction heating most of the time. This is a very intelligent and clever solution because it applies with a much smaller quantity of energy the use of kilowatt to heat up directly the plastic. What does it mean? Traditionally, your extruders has a set of electrical resistances to heat the barrel. Barrel is a big piece of steel, and you have to warm up the steel first, then the steel warm up the plastic. Finally, the plastic melt down or gellify in case of viscous materials. But if we are going to heat up directly the plastic without heating the barrel, we obtain an immediate saving of a big energy dissipation. The waste of energy dissipated by the screws and the barrel is avoided, and the energy is directly used to gellify or to melt down the plastic only. Truly speaking, you teach me, warming the water in the pot, automatically the water transfers its temperature to the pot. We are also using and observing the same case. Our energy through the induction heat up directly the plastic. But the plastic during the continuous processing reverse some of the energy, warming up partially the barrel. Traditionally, a typical electrical resistance heated barrel is very hot, and you can have problems in touching with your hand without protection. On the opposite, induction heated barrel allows you to put your hat or your hand, and the temperature is much smaller. So no way to cook your eggs for the morning breakfast on the barrel of induction heating system. But the saving of the energy represents more than 30%. And this is a benefit for our customers, choosing to have better consumption and a lower effect as a carbon footprint in the world market. Many companies are strongly investing to reduce their carbon footprint. Other companies are interested to save the money and to optimize the cost behind each kilogram, each ton of product manufactured. In both cases, induction heating system, additionally to our multi-drive, allows you big benefits and big savings. Bigger the output, bigger the saving. That's why our machinery, especially the big size, as well as the average size, represents for our customer a strong investment with a much quicker return of investment. Where is convenient to spend your money? In a strong return of investment or in a lower cost machine that consume day by day more kilowatt? This is the question. I allow you now to pass to Alessandro Ruotolo, our test room manager. Alessandro, are you ready?
Today we will show you one granulation process with our MD9225 boson extruder for granulation of foam PVC for shoes. Now I'll shortly show you the composition of the line that we are using for our extrusion test. Starting from the rear of the extruder, we have 4 motors empowered in 3-phase, 15 kilowatts each. Between the motors we have a load cell that directly measures the thrust-bearing back pressure that is visualized on the main control panel. The motors are connected to the drive system with the reduction ratio of 41.5. Inside that cast iron casing is housed the complete drive system of the extruder. There is our multi-drive gearbox already presented by my colleague Alfeo Bonato. After the gearbox, we have the loading system, the feeding system of the extruder. We have a stainless steel hopper, and inside the hopper we have a vertical screw conveyor that directly takes the material and load the material on the screw feeding zone. The screw is moved by a motor of 3 kilowatts directly commanded on the main control panel of the extruder. On the feeding system we have a manual jack that easily allow to lift up all the system in order to check and clean properly the feeding system on the screws. Then we have the barrel. The barrel is made in nitrated steel. It's heated up with our induction system that is composed by different heatings with different installed power. The first one is 3 kilowatts as installed power, then 4.5, and then up to 4 kilowatts up to the end of the barrel. The barrel cooling system is composed by cooling fans starting from the second zone up to the end of the barrel. Here I show you the degassing system. The degassing system of the extruder allows to take off all the gases that are developed during the extrusion process, and it's 2/3 of the barrel. Here we have 2 small barrels that are inspectable through 2 small plexiglass glasses and also easily cleaned. We can switch during process without stopping the process from one barrel to another in order to clean the degassing system. The vacuum pump is a liquid ring pump of 4 kilowatts and 120 cubic meter per hour. Now I show you the die of the extruder. On the die, on the collector, here we have other 2 heatings, metal 2.5 and 2 kilowatt each. The granulator from which the granules come out is a 3 rows of hole granulator with a heavy hose of 3 millimeter diameter. The rear of the granulator has got an ogive that allows to accelerate the material flow inside the collector and uniformly distribute all the material inside the holes of the final granulator. The cutting system guard allows an internal air circulation force for cooling down the granules coming out of the die. Here we have a lamp that allows an easy inspection of the quality of the granules that is coming out from the die. The cutting system is composed of 3 blades that are assembled on a throttling head that easily allow the assembly process on the die, provide uniform pressure on the die head, and allows to have a uniform size of the granules coming out from the die. The motor is a 3 kilowatt motor and is directly commanded and set from the main control panel of the extruder. Then the granules are launched by this launcher with the startup command from the main control panel and are directly sent to the cooler cyclone. The throwing pipe is jacket and water cooled in order to provide the total separation of granules and avoid the granule stickiness. Inside the cyclone, we have a filter for the granules. The granules are directly thrown inside the cyclone. There is installed steel, and on the bottom of the cyclone we have a filter in which the granules are filtrated and moisture content start to be taken off. Then the granules come on a vibrating tray hollow on which the granules are completely cooled down. Both the vibration and intensity of cooling fan can be regulated through the small control panel on the cooling system. Here, the granules are coming out from the cooler totally cooled down. Here we have a conveyor tray that takes the granule to the final hopper. Here the final tray can be removed and it's also interchangeable in order to select the granules dimension through the dimension of the tray holes. As you can see, the granule quality is very, very good. The granules are totally jellified and the dimension of granules is uniformly distributed on all the granules. Now I will show you our main control panel of the extruder. Now I'll show you our digital extruder control 4.0 that is configured for our Nextomover configuration. Here on the main page we have all the motors of the extrusion process. Here the cutter, then the extruder screws, and then the forced doser. Here we can check, monitor and set all the parameters of the process. And we can also check what is the pressure of the die head inside the collector. That is measured through the pressure and the temperature transmitter directly on the material inside the collector. Here we have the wall amperage of the machine, and this is the back pressure on the truss bearing. On this small panel we have all the energetic parameters of the process in terms of power consumption. Here displayed we have the total output that we are achieving now of 600 kilograms per hour of granules of soft PVC foam for shoes. On the next page we have all the temperature setting of the machine, starting from the cooling of the screw that are internally cooled down to the circulation of silicone oil through one central unit. Then we have all the set temperature in white and measured temperature through thermocouple in gray for the heating of the barrel and the collector. This is the melt temperature. There is the temperature of material directly measured through the temperature sensor inside the collector. We have also other pages. There are maintenance page in which we have all the basic maintenance process that we can do on the extruder, and comes also in the alarm page, in which we have the page of all the activated alarm and also the maintenance process. As previously shown, here we have other pages that are useful, for example, to set the preheating time of the extruder. Now I come back to the main page, and that's all. Thank you for joining us, and now I leave the floor to Mr. Clemente Bausano. Thank you.
Just to summarize what we have seen today during the test, we have run a trial with our MD92 Twin Screw Extruder processing foam PVC for shoes, so shoe grade foam PVC. The extrusion model is a Nextomover series, and it's equipped with our multi-drive worldwide patent gearbox transmission system with high efficiency motors, AC motors, with the barrel induction heating system, and with how can I say, with Industry 4.0 device that allows the extruder to be connected with the factory itself, with the network of the factory in any moment. So this is what we have seen today. I would like to thank Alfeo, Giovanni and Alessandro for their support. And so now, if there is any question, I will be glad to reply. Okay, first question then is coming from, let me check on my iPad. This is from South America. Okay, this is Mr. Esteban. Esteban is asking about 4.0 system. What is 4.0 system and what's for? What is the use of it? So our extruder is equipped with this integrated control system that perfectly fits the 4.0 industry requirements. So it means that our extruder is ready to be connected, as I said before, is ready to be connected with the factory, with the company network in order to collect and process all the data that are necessary to control the production of the line. Apart from that, what is of utmost importance when we talk about 4.0 industry is that these instruments can be used also to predict and to prevent somehow the maintenance program on the extruder. So it means that taking care of the data of the extruder itself and following the day-by-day running of the extruder, it is possible to program the maintenance of it in a precise span of time. So this will help the company and the customer to save precious time in case of some necessity of check the status of the extruder, and also to plan in an easier way the control by our technicians or by the technician of the customer itself on the extrusion line. So all of our extruders are compliant with the 4.0 regulation. Another question? Yes. So this is from North Africa, Algeria, I guess. I'm translating from French, sorry, because the question came in French. So, how are screws designed for your counter-rotating extruders? Yeah, this is a very, very interesting question because this is really the heart of the extruder. So, in Bausano, as maybe someone of you already know, we design and manufacture all of our components, at least all the main components of the line. So it means that gearbox, screws, barrel, and all those main features are designed and manufactured in-house. Amongst these components, for sure, one of the most important, or I would say the most important one, are the screws, especially in case of twin screw extruders. So it means then anytime we sell a line to a customer, we always start, before designing the screw, we always start with doing some laboratory analysis on the material that the customer is going to process. So we start from some small quantity of raw material in order to get some results, some parameters, to be used in a special software that we have developed along the years to finally get the inputs to design the screws that perfectly fits to the customer necessity. So it means that it's a long process, and this process requires a high competence, a high skillness that we do have actually in our company. And so once the screw has been designed, we proceed with the manufacturing of them. That will take place in our company, in our workshop, where we have the thread milling machine, etc., etc. So we can say that we can really manage the complete process of screw designing and manufacturing in our factory, in our company. Yeah, and this is the most important point. One more. Could you give us details of your biggest extruder models? So this question is coming from Rajasthan. This is from India. Very nice. I've never been there, but one day I would like to go there. So Rajasthan. Yes, of course. Our biggest extruder at the moment is the MD 170 millimeters. It means that these are counter-rotating twin screw extruders, and the productivity, they are also asking about productivity. The productivity is depending on the raw material to be processed, of course, but let's say that it's about from 2 to 3.5 tons per hour, more or less. Yeah, this is really a huge extruder, and it's a very good success. Another question. The PVC mousse, as you mentioned in your presentation, it means foam PVC or expansion PVC. No, what we have done during the trial was foam PVC. Foam PVC for shoe application that is getting more and more popular. Yeah. I personally witnessed a great boom of foam PVC for shoes, especially in South America. Okay, next one. Is there any numerical comparison of energy input, kilowatt, kilogram produced, comparing this new technology against the current one? Yes, there is a comparison. What I can say is that, okay, let me open a small parenthesis on the induction heating barrel system. Yeah, the technology, the induction heating system of the barrel is something that it's a new feature that we have just introduced on our extruders. We are the first to equip the extruders with this induction heating system on the barrel, and compare, just to go back to the question, compared to the normal ceramic heating system of the same barrel. So if we compare two equal extruders, we say that with the induction heating system we can save, compared to the ceramic heating system, we can save about from 20 to 30% of the energy consumption. So it means that the ratio kilowatt kilogram, it's really most favorable in case of induction heating system than ceramic one. Another question. Have you supplied the WPC extruder lines to any manufacturers in Gulf countries? For example, Dubai, Qatar, Bahrain, Saudi. Yes, we did, but I think I cannot tell where. Yeah, it's better not to tell. Yes, we have supplied, yeah, more than one actually. One more. What is the highest output the Nextomover series can handle? As I said before, if we use the MD170, that is the biggest, we can reach more than 3 tons per hour. Let's say 3.5 tons per hour, more or less. What is the idea behind the development of the induction barrel heating system? The idea is exactly, the idea comes from an analysis that we did on the overall cost of our customers. So we understood that one of the most important costs of our customers, apart from raw material of course, is the energy cost. So we have concentrated our efforts in trying to find a solution and help the customer to save as much money as possible under this point of view. So we have developed this induction heating system that is related to the barrel. And we have equipped our Nextomover series of twin screw extruder with this induction heating system that works as not by heating a ceramic resistance like the traditional ones, but is working through the electromagnetic waves. So the induction system is something that was already existing, of course, but has never been applied to any extruder in particular. So what we did is taking this technology that is something known and to use it for the extruders. So we really got incredible results because we have done many tests, we have compared many extruders of the same category, of the same size, working, keeping one with the traditional system and the other one with the induction heating system. And we have seen, as I mentioned before, that you can easily get, let's say, minimum 20% of energy saving on the cost of the energy for the barrel heating, but you can also reach up to 30%. So if you consider how heavy is the cost of the energy on the total balance of a company, you will really understand that this is something it is worth spending in. One more. Will there be a video made available for today's webinar? Yes, a video of the whole webinar, especially of my very much interesting interview, will be available soon on our webpage with the same link. There are many people looking at me actually. It's okay? Another question. Can the MD series of, for example, 5 years ago, so we are talking about previous MD, Twin Screw Extruder. So can the MD series of, for example, 5 years ago be upgraded with a higher efficient heating system like the induction heating? Yes, of course, it can. Yeah, of course, it's possible. It would be probably much easier to have the extruder here to do the upgrade than doing directly on the customer at the customer site, but it's very much possible, yeah, for sure. Does induction heating works with polyolefins? Yes, of course. I would say that it's especially because polyolefins require a high temperature. This system is even more interesting when we talk about polyolefins because, as most of you must know, when we talk about PVC, we work at 150, 160, 180 degrees maximum. But when we talk about polyolefins, we talk about 200 degrees plus. So, especially in polyolefin, I see a huge advantage in using the induction heating system. One more. Okay, this is something that we are interested to receive the standard formula, the standard recipe of the foam PVC compound for shoes. Okay, we will get in touch with you. This guy is calling from Moldavia. Moldavia is Eastern Europe. Okay, so guys, now I have to go and get a coffee, so you cannot bother me that much. I already talked too much today. So thank you very much for having attended the exhibition. Thank you very much for your courtesy and kindness. I hope to see you in the next webinar online. Thank you very much. Bye-bye. If you are, yes, they are telling me to tell you, if you have any info, any question or whatever, please write at info@bausano.com.